All right, so this is limits for absolute values, and we're going to start with a basic one and then go on to some tricky ones. So with the absolute value, what we're going to do is just basically convert it to a piecewise function. So we want to find the limit as x approaches 0 of the absolute value of x, and we want to show that it equals 0. So we go back to what we did before, and if you remember, it's negative x for x is less than, and you can put the equal here, than 0, and it's positive x for x is greater than 0. Doesn't matter where you put the equal, especially because we're doing a limit too. So now when we do a left-hand limit, we would pick the negative. So again, this is our left, and this is our right. So doing the left-hand limit, we say the limit as x approaches 0 from the left of negative x. And now we can plug it in with our substitution property. So that's just 0. And then we do the other side, limit as x approaches 0 to the right, and that would be the positive x. And so then we plug in 0 and we get 0. Therefore, the limit as x approaches 0 of the absolute value of x is 0, because the left-hand limit and the right-hand limit both approach the same thing. And we already knew this graphically. It's a v. So coming in from the left and coming in from the right, they are both approaching 0. All right. All right, so now we're going to use this same exact thing over and over and over again. So what we have inside is 2x plus the absolute value of x minus 3. So remember, our x minus 3 would just be this for the positive and this for the negative. And so we can extend that. We can now say that 2x plus the absolute value of x minus 3 is equal to just putting a 2x in front of it. And putting a 2x in front of it. Like that. And so now you can see that this is our left, and this is our right, and now we just find them. So let's start with the right hand limit first, since it's on top. So the limit as x approaches 3 from the right of 2x plus x minus 3, and now we can use our direct substitution. So 2 times 3 plus 3 minus 3, and that would become 6. And then we do the same thing here from the left. So 2x minus x minus 3. And if you don't remember where this came from, please watch the video before for absolute values, converting them to piecewise functions. And so this is 2 times 3 minus 3 minus 3, and that also equals 6. Therefore, the limit as x approaches 3 of 2x plus the absolute value of x minus 3 would equal 0. And we want to not 0, 6. And we want to verify this in our calculator. So let's pull up in our TI and check it. So it's 2x plus, and again, to get to the absolute value, it's math, and then number, absolute value, x minus 3. And again, we go to our window, and we want to make this around 3. So 2 and 4 for x min, x max, and then zoom 0. And there's our split. You can see our absolute value split right there at 6. So if we hit trace 6, or 3, splits at 3, we get 6. So there's our limit coming in from the left and from the right. It's both 3. 6. It's both 6. So coming in from the left, we are approaching 6. Coming in from the right, we are approaching 6. So our limit is 6. All right, let's try our last one. So this is the most complicated one I could find for a basic problem. So we have the limit as x approaches negative 6 of this. And so before we even start, let's make sure that it does simplify, because it says right off the bat that it does not exist. So we're talking infinity, negative infinity, but let's check it anyways. So if we plug in negative 6, you would see that on the bottom we get a 0, and on the top we also get 0, which means this can be simplified. So we're going to be doing some simplifying. So the first thing you want to do is factor out that x squared on the bottom. And the reason we do that is if you take out an x squareds work as absolute values. So it allows you to remove the absolute value from them, revealing just our x plus 6. This allows us to put it in piecewise form. So this becomes this. And so now we can write it as a piecewise function. So if you remember, x plus 6 will become negative x plus 6 for the numbers less than or equal to negative 6. And it becomes x plus 6 for the numbers greater than or equal to negative 6. And that's what the limit is approaching, negative 6. So we know that we use this one for the left and this one for the right. I have an equal on both. I need to pick one. There we go. So now we can write this all together. And so we say 2x plus 12 over x squared, x plus 6 would equal, and we're going to just place these two in their proper location. I'm going to need a bigger brace than that. Let's just write it first and then rewrite it. So it's 2x plus 12, x squared, and then this would be the negative. I'm going to write it as what it is, x plus 6, like that. For x is less than or equal to negative 6, and then it's 2x plus 12 for x squared, x plus 6. So we're just placing them in their proper location. And there we go. So now we can do a left-hand limit for the top one. This is our left, and this would be our right. So let's start with the left. Okay, so the limit as x approaches negative 6 from the left, that would be the other one, so the top one, 2x plus 12. I'm going to bring the negative out, giving me this. All right, and then now what I can do is factor the top. So the limit as x approaches negative 6 from the left, factor out the 2. And that's the canceling part that we're getting. So we're getting rid of that x plus 6. And that makes sense because remember the negative 6 here is what we plugged in. So we would want that x plus 6 there because it's giving us that 0. So this now becomes the limit as x approaches negative 6 from the left of 2 over negative x squared. We can now do our direct substitution. So 2 over negative 6 squared. And that would become 2 over negative 36, which is 1 over 18. So that's our left. And now we do our right from the positive. And so it's just going to be the same steps. We're going to take and plug it in, factor and cancel, and get it here. And you can probably already see that this one has the negative and this one has a positive. So that negative is being carried through, and it's what made our answer negative. And so now this one doesn't have that negative, so it's going to become positive. And there you have it. So x squared, x plus 6. And then this equals the limit as x approaches negative 6 from the right of 2x plus 6 all over x squared, x plus 6. They cancel. And we get the limit as x approaches negative 6 positive of 2 over x squared, which would become 2 over negative 6 squared, which is 2 over 36, which is 1 over 18. Are they the same? Therefore, the limit as x approaches negative 6 of our original expression, 2x plus 12, over x cubed plus 6x squared, does not exist. And there you have it. So that's our value. But you still want to check it with the calculator. So what we're going to do is plug this in our calculator and verify it. So alpha y, and then we do 2x plus 12 over math absolute value, and then x cubed plus 6x squared. Forgot the x. Put them in there. All right. And then now we're going to go to our window, and we're looking at negative 6. So negative 6.5 to negative 5.5 for our max. Zoom 0 to fit it, just like before. And you can see one is going to our negative 1/18th, and the other is going to our positive 1/18th. And so if I hit trace at negative 6, you can see it doesn't work. But if I go a little bit to the left, you're getting that negative 1/18th. to the right, that other negative 1/18. And so plugging it in the calculator, you can see that's exactly what we were getting. 0.556. So again, hit trace once it's done. Scroll to the left, and you can see there's your 0.5554, positive 0.5557. It's that 1/18. And there you have it. Thank you.